Hey everyone, and welcome to the lesson on isosceles triangles, in particular their base angles, as well as kind of adding that into our toolbox for working with angle chases. So first thing that I'll kind of show here is probably more with isosceles triangles, but I'm going to come back to this warm-up. So if you are kind of working through it and or struggling with it, you can kind of catch how I'm going to do that at the tail end of this video, because the lesson itself shouldn't take all that long. It should be a pretty quick day for everybody. So I'm just going to skip over this for right now. Amounts to kind of solving the missing angles that are shown in the diagram, but we'll talk about that. And here's really where we're just going to be putting our notes for the day. So in an isosceles triangle, so the first kind of component here would be to let you know what an isosceles triangle is. So that's a triangle with two congruent sides. Okay, so I've drawn an isosceles triangle, and I've got my congruent hashtags kind of, or markings on the left and on the right. And the important thing to kind of note, and we probably surmised this yesterday with some of our diagrams, but these base angles, so these are considered base angles, and those are congruent to one another. So if I have this as angle 1, angle 2, my notation would be angle 1 is congruent to angle 2, or I can say the measure of angle 1 equals the measure of angle 2. So that is important just to kind of realize, because we might have a diagram, in particular this diagram here, where you would be unable to kind of finish out this diagram if we didn't pay attention to the fact that, oh, I've actually got an isosceles triangle here. So I can say something about the base angles in that. And even though this triangle is oriented slightly differently, we should be able to identify our base angles as being opposite of those sides, okay? So that's just kind of a little bit of help once we get to that diagram. Another thing that we can kind of get from this, even though I wasn't necessarily intending to take a look at it, is if we have an equilateral triangle. So this would be an equilateral triangle. So equa meaning equal, lateral meaning sides. So all sides are the same. Really, we end up with this fact that all three angles are the same. And this makes sense even if I just look at it from the perspective of an isosceles triangle. So if I know, basically, if this is isosceles, I know that 3 is equal to 1, but then we also know 1 is equal to 2, and then I could also say that 2 is equal to 3. So then we know that all of those angles are actually congruent to one another. So equilateral becomes a little bit more powerful because I can also just say, oh, that every angle has to be 60 degrees. I can't do something, I can't do that same thing here, be able to tell what those angles are without being given at least one of those angles. But it's also important to realize that as soon as I'm given one of those angles, then I can go and figure out the other two. So as an example, if I know that this is 70 degrees up top and the sum needs to be 180, that means that these two missing angles have to be 110. And then if I know that they're the same, then I could say that they're both 55 degrees. Okay, so we start to see why knowing that those are congruent is kind of important for us. So there's two angle chases below, and that is the primary kind of work for the day if you've already done the warm-up. If you haven't, I'm going to take a look at it right now. And if you're feeling comfortable about the warm-up, then you're welcome to kind of, you know, depart this video and work on the rest of these two angle chases that you have. All right. So for folks that want a little bit of support on this warm-up, I'm just going to go through kind of how I'm thinking about it. And the first thing that I would pretty much highlight is that I have these two parallel lines. So I have a bunch of angle relationships if I want to use them. The first one that I'm going to kind of make note of is this 160 degrees has to be equivalent to R. And those are corresponding angles. Once I map those, then I can pretty much get these other pieces. Okay, so R and P form a linear pair, so those have to add up to 180. R and this angle, even though it's not being asked for, are vertical angles, so I can also kind of put that one in there. And now it appears like, it's a little bit harder to get into this triangle here. But then if I go back to that 160 degrees, I can say, okay, well, we know this is 20 degrees. And now I'm inside this little tiny triangle where I have 20 degrees and 60 degrees, which makes 80. So then this angle here has to be 100. So then this has to be 100 as well. Now I've made it into this triangle, so the sum of those has to be 180, and I'm at 120, so I know x is going to be 60. And finally, I know x plus s is 90 degrees because it needs to be supplementary to that other 90 degrees. So this is then 30 degrees. So if I was kind of just making note of these as I have them, this is 60 degrees. R looks like 160, and then P looks like 20 degrees. And the nice part here, so kind of demonstrating a few different pieces, I wouldn't just fill these out because it's helpful to have the angle measures on your diagram as you're completing them. But then this is kind of nice from a teacher standpoint, or if you're checking work against somebody else, to just be able to say, oh, I got 60, 20, 30, 160, 20, in order to kind of compare those results. All right, hopefully we're getting some of that practice in with angle chases, and we'll keep kind of extending upon those for a little bit. Thanks, everyone. Have a good